Buenos días, señoras y señores. Now, a few skirmishes going on. First of all, the absolute light thing. When I say I'm sure of it, that light is absolute, it's not finite. That does not mean if it turns out to be a local sun, when it's over here, let's say Africa, it's something like that, it won't be seen over in America if it is a local sun, which is what is being suggested. Absolute light, it's the speed at which the light gets to where it's going. Instead of taking 8 minutes and 20 seconds to get to here from the sun, it would just go boom, and it's here. Absolute light means that wherever that light is going to reach, it does so, bang. Photons, massless, invisible. Red flag, folks. Bang. There's nothing. There's no resistance. There's nothing. If a light is going to reach somewhere, it's there at the onset. Boom. That's what I mean by absolute light. Not distance. It's the photon. It's the finite light. The one that reckons it travels forever. But it doesn't, does it? So if it were local, it does not mean the whole flat Earth would see it. Look, this stuff is new. I've been a glober all of my life. There are still questions. There are questions about the round one as well, aren't there? Like gravity. On the moon's gravity. The people that keep saying, well, yeah, another moronic post. What are you talking about? No. I'm not sure why people are saying that, because what I'm talking is 1 + 1 = dos all of the time. The moon, for this exercise, this is so spontaneous actually. Look, when I say the moon does not exert any gravitational force on the water, I'm saying it for a few reasons. Not one, it's not a hunch, okay? Number one, it's orbiting us along the equator, isn't it? Right? It is a fact, okay? So we've locked that one in. If that is the case, and they show you the bulge, they draw you pretty pictures. Where would the bulge be? If the moon and its gravitational pull, it's all orbiting us along the equator. Along the equator, that is where you would expect the bulge. So why is it that the 4 highest tides are all up north? The Bay of Fundy, Ungava Bay, the Bristol Channel and the Cook Inlet. Why? Only logical answers, please. And why is it that along the equator line, or close to it, the Gulf of Mexico, the Mediterranean Sea, the Bahamas apparently, there is very little tidal action the whole year? Why? There is no logical answer. There is only one logical answer. That's slack water. The tide comes in for 5.5, 6 hours. It comes to a stop at the high, and it can stay like this for up to an hour. And then after that hour is up, it drops, but it goes back the same way. How on earth is that spinning around that, giving an opening for this? Or some of the lowest tidal waters along the equator, and the highest all up north. That is why. It is not This one belongs to next door. Yesterday, Boogie, throw our ball back over. I looked at it and go, whoa, that looks like a good Venus, a good Mars, and I'm using it for the moon now. I said, no, it's not here. You know the orange one that we use? No. Maybe you threw it too hard and it went over my yard and into the other neighbour's yard. I'll have a look after. But I'll throw it back this morning. Now, the next one. when we have a lunar eclipse, I saw this on Flat Earth Dave's thing, okay? And I just like to do it to follow up, because I've had people ask me, why do we only see a sliver of the moon and then it disappears? And I don't know why people are asking me. I do know why it happens, so I'm going to explain it. But I'm also going to explain how it isn't Earth blocking the sun when there is a lunar eclipse, when we see the moon disappear, right? And it's supposed to be Earth's shadow, but it isn't. And I'm going to show you why. Right. Now, which one should we do first? Let's do the moon phases first, right? Because it usually only takes a second. Right. Put this light on. There's something a bit odd about these moon phases as well. The fact that we can't see the sun for 2 days. The moon. Some sorcery going on there. Let me shut this door. Alright, so what we have. So we are now, I'm going to use this here, right, as the moon. We're in the, looking that way, and see the shadow. Right, so we're in the full moon position. So we see all of the moon. It's orbiting us like that. So we're Earth, we're going to follow it round. So it's going round. Now, as you'll see, because the sun is to our left, as we move around, now see that? It's coming up, the shadow is creeping up from behind, right? And there we have the first quarter. All it is, it takes 24 hours to 28 days to orbit us, right? So every day it's a little bit further across, Then eventually, see how we get that sliver? And then, bang. And in this position, we're in the solar eclipse, aren't we? The moon has block the sun. The thing is with this, right? We don't see it for 2 days. This is the solar eclipse position. We see the outline, we see the corona, don't we? But when it's in any other position like this, we don't see it. Even there, it's just moved out of the way of the sun. There is always going to be a little sliver as soon as it moves away. Because if that sun is that distance away from us, why don't we see it for 2 days? Where is it? It's not directly in front of the sun, because that would be the solar eclipse. If it's anywhere, you see how you get that shine? Doesn't matter where it is. If it's moved away from the sun slightly, there is an angle that we should see it, but we don't. Right? Well, that was just another one of the Russell observations, because I find it very strange that we don't see it for 2 days. I know there'll be people saying, oh, yes, we do, but stop it. Show me why. I've just shown you why I think we should, because if it moves out of the way, the sun, there's an angle for the sun to bounce off of it, and we don't see it. It's strange. Right. During a lunar eclipse, when we block the sun and the moon falls into our shadow, what we see happen is this. So we're going to use this one, right? It's roughly the same size, or this one's a bit bigger. I could use the other globe, right, just to keep it. Oh no, it doesn't really matter. Right, now what we have, we see this, right? Now you see that is a curved shadow, and it ends up creating a bit of a C even, doesn't it, there? Right, you've got that left-hand side, and then it's totally covered up, and then when it uncovers, again, it's got that curved shadow, right? See that? And you see it. This is not how it should be. The reason being, Earth is blocking the sun onto the moon. Now, the moon is a lot smaller than us. This is what would happen. This is what we should be seeing because of the size of the diameter of Earth. It's 3.6 times the size of the moon. Now, this is what would happen. You get a straight line. See that? Hola. I'm just going to pause you. Don't lose train of thought. Don't lose train of thought. Train of thought, don't lose. There we go. Lovely. Now, so again, let's go from the bottom up. See how it's a straight line. And when it uncovers, doesn't matter which side we come from. It looks like curved as it's coming up, but because of the size, it's a straight line. We never see that. And when it uncovers, a straight line. See that? It's because it's the size of the objects blocking the smaller object. That is what we would expect to see. And then when it uncovers, it's a straight line as well. All right? Not that, and that is what we do see. It is not Earth's shadow that is moving across the moon. If it was, it would have been a straight line. So what is it then? What is it? What are you saying? You know what we're saying. Don't have the specific, all of the details, but nor does the rounder. Like I said earlier, what's the explanation for the tides? It's not the moon. It's impossible. Those three facts. Send it home. I'll throw it over the fence right now if I have to. Well, I will actually. It's not the moon. So what is moving the tides? What is moving the water? And how on a sphere? There is no curvature. It's not just one thing. And it's not just me. There are lots of things going on, and there are lots of people wanting answers. I'm not understanding why the general population on hearing this would not want answers too. These are all logical, perfectly reasonable questions. What is moving the tides? Why is it that we see a curve, shadow, move along the moon when we have a diameter that's 3.6 times as big as the moon? It's illogical. It isn't Earth's shadow moving over the moon. It's another thing, see? All right, folks, I will be back a bit later, and we will finally have a look at all of these words. See if there's a couple of coincidences there, all right? All right, folks. Gracias. See you later.